Section 7, Metaprogramming. 7.1, Using Function Decorators. We're going to look at what a decorator is and how to make one, how to add data attributes to decorated functions from decorators, how to wrap a function from inside of a decorator so that its parameters and return value can be processed, and how to make parametric decorators that accept parameters of their own. Metaprogramming is a blanket term for techniques where programs use program code or data structures constructed directly from program code as data to be manipulated. Python has a number of different features that can be thought of as metaprogramming, and in this video we're going to take a look at one of the most ubiquitous, function decorators. The basic definition of a function decorator is simple. It's just a function that takes another function as its input, does something with it, and then returns the result of its operations. The return value replaces the original input function, so the changes a decorator can make are potentially quite drastic. A decorator that doesn't change anything at all is a function that accepts one parameter and immediately returns it. Python has a special syntax for applying a decorator to a function, using the @ symbol. Using this syntax, we just write an @ symbol followed by an expression that evaluates to a decorator function. We put that on a line right before the definition of the function we want to decorate. This syntax means, as soon as you're done defining a function, call the decorator function on it, and then assign the return value of the decorator to the variable that would have contained the function. It's also possible to use multiple lines before a def, in which case multiple decorators will be invoked. The decorator that's closest to the def will be called first, then its return value will be passed into the next closest decorator, and so on. Eventually, the return value of the topmost decorator will be assigned to the function's name in the containing scope. In this example, the variable foo ends up containing a of b of foo. One of the most common use cases for decorators, and in fact the reason they're called decorators, is to add attributes to function objects. These attributes can be used by code in other parts of the program to distinguish decorated functions from each other and from undecorated functions. This is easy to do. Inside the decorator, we assign attributes to the function just like we would to any other object, and then we return it. Then, elsewhere in our code, we can check for the attribute and respond accordingly. That's all well and good, and often quite useful, but we can do a lot more with decorators. For example, we can enclose the function in a wrapper that performs some computation before or after calling the original function. To do this, we want to define the wrapper inside the decorator. If you haven't seen this before, it means exactly what it looks like. The definition of the wrapper function is actually inside of the intsOnly function, so when intsOnly is called, it defines and then returns a wrapper function. Each time intsOnly is called, it defines a new wrapper function. When a function is defined inside another function, the containing function's local variables remain available to the inner function. That means that our wrapper function can use the func variable to refer to the wrapped function. In this case, the wrapper does some manipulation of the function arguments and then calls the wrapped function and returns its result. We imported and used a decorator called wraps in the last example. The wraps decorator's job is pretty straightforward. It makes the wrapper look like the wrapped function to tools like PyDoc and help. However, you may have noticed when we used wraps that it took a parameter. How does that work? If a function decorator always accepts just one parameter, and that's the function being applied to, where did the other parameters come from, and where did they go? The key is that the @ symbol isn't followed by the name of a decorator per se. It's followed by an expression that evaluates to a decorator. So wraps isn't actually a decorator. Strictly speaking, it's a function that returns a decorator. When Python evaluates the function call expression, wraps returns a decorator function, which is then applied to our wrapper. If we wanted to modify our intsOnly decorator so that we could specify an arbitrary function that would be applied to all the parameters, it would look like this example. So now we have a function called only, which returns a decorator, and which in turn returns a wrapper, which calls the original function. That might look terribly inefficient, but in fact the only overhead comes from invoking the wrapper each time that we can call the function. The outer two layers of code only run once when the function is defined. So decorators are just functions that take a function as their argument and return a function, or generally a function. The return value of a decorator takes the place of the decorated function, which is why the return value usually is a function. A decorator can add attributes to a function and return it, or wrap it and then return the wrapper, or even return something else entirely. Any expression that produces a decorator as its result value can be used with the @ syntax. So that's how to use function decorators, and a taste of the sorts of things we can do with them. In the next video, we'll take a look at another programmable syntax feature of Python that meshes nicely with function decorators.